Okay, so this is lesson 2.2. Some basic differentiation rules. Really what these are shortcuts to keep you from having to use the limit process. You still have to know the limit process for some problems. Okay, the first one is the constant rule. Which simply says that if you're given a constant function, such as f of x is equal to c, where of course c is a real number, then the derivative of c with respect to x is going to be 0. And if you think about that, that makes sense because f of x equals c is a horizontal line. F of x would be like y. C is some real number. Let's say that it's -8. And the slope of a horizontal line is 0. So therefore the derivative of some constant number is going to always be 0. Okay, the next one is what we call the power rule. And that just says that if you are given the function f of x is equal to x to some power of n, where n is a rational number, then the derivative of x to the n with respect to x is going to be whatever the power n is. We're going to bring that down in front of your function, times x times n to the -1. So we're going to decrease that power by 1. Okay, so for instance, let's say, I'll show you some little quick examples here. Let's say that f of x is just equal to x. Then your f prime of x would be equal to, here we go, you have an understood power of 1. So we would bring that 1 down in front, bring down the x, decrease this power of 1 by 1, and so that would give us x to the 0, which really is just 1. Okay, and you'll actually see that little pattern with linear functions. Let's say that you have f of x is equal to 1/2 x, and you want to find that derivative. Okay, 1/2 is your coefficient, also known as your scalar multiple. So what you would do here is you still have a power of 1 up there. You would just bring that 1 down in front, and it would be multiplied times the scalar of 1/2. Bring your x down. You would still decrease that power by 1. So what we get here is 1 times 1/2, which is 1/2, times x to the 0. And of course x to the 0 is 1. So your derivative of x is just 1/2. And see, that is your, you're going to see that pattern with linear functions every single time you do it, to the point that you could get to, or when you see like a negative 5 times x, you can say, oh, this derivative is just going to be negative 5. It's going to be whatever the coefficient of x is. You can do that with whatever. Notice here it says that the power has to be rational. The coefficient of x does not. So like if you had pi times x and you wanted to get the derivative, it would still work the same way because pi would be your scalar multiple. Your power is still 1, which is rational. So, a shortcut method would be to say, oh, that derivative is just pi. Okay? So it's just the coefficient of what x is. Sometimes you have things that are a little more complicated than that, of course. Okay? Let's say that f of x is equal to x to the third. Okay? Then, following that rule, you would take your power of 3, bring it down as the coefficient, decrease that power by 1. So there you have your derivative is 3x squared. We have done that several times using the limit process to the point where you have that memorized. Okay? Let's say that f of x is equal to, let's do 2 times x to the negative 1/2. Okay? Again, we've got the scalar multiple in front of x, so we still bring this power down in front. We're going to multiply it times the scalar multiple of 2. Bring down the x. Decrease this power by 1. Get hooked on fractions and signs and make sure you get them right. And so that gives me negative 3/2 right there. So the derivative of f, this is going to multiply to be negative 1x to the negative 3/2. And that is your derivative, and you can leave it that way depending on, how the question is worded and what you're going to do with it. Okay? There are some problems that you'll encounter that you may want to rewrite before you take the derivative. You're going to want to rewrite it into this form right here as x to the n, because it won't always be written that way for you. So let's say that you have like 2 over 3 to the x to the 4th. What you could do is the x to the 4th could be brought up. So here I'm just going to rewrite it. It can be brought up to your numerator, and you can write this as 2/3 x to the negative 4. So now it's in that form of x to the n, and where 2/3 is your scalar multiple. So when you actually go to take the derivative, you can still bring that negative 4 down in front, multiply it times that scalar, bring down that x, decrease this power by 1, and then simplify all of that. Okay, so that would give me negative 8/3 x to the negative 5. You can leave it that way. If you wanted to clean it up some more and write it as negative 8 over 3x to the 5th, then that would be fine too. So some of these problems you may have to rewrite as a power function before you can use that power rule. Okay. Let's take a look at this one here. 3x to the 4th minus 2x squared plus 5. Let's throw in a plus 7x just for kicks. Okay. Here we can look at this as the sum of 4 different functions, and we can take the derivative of each one of them separately. So we can take the derivative with respect to x of 3x to the 4th, and then take the derivative with respect to x of negative 2x squared. And then, let me slide this over a little bit, and then plus the derivative with respect to x of 5, and then take the derivative with respect of x to of 7x. Okay, so you're just looking at these as being the sum of 4 different functions. So I am going to bring the 4 down in front, multiply it times the 3, and decrease this power by 1. Here I'm going to bring the 2 down in front, multiply it times this -2. Decrease that power by 1, I just get x to the first. Here, remember that the derivative of a constant is just 0. And here, remember that the derivative of a line is simply the slope, which is the derivative of that line, or the slope of that line, which makes sense because derivative means slope. Okay, and then we can clean this up, and we can make this 12x cubed minus 4x plus 7, and then that would be our answer. You do not have to do this step for me right here. You can just do that in your head. I'm fine with that. Okay, I was just wanting to break that up for you to show you that this was the sum of 4 different functions, and that you could use your power rule on each function or on each term. Okay. The derivatives of sine and cosine. These are some you're going to have to memorize. Eventually we're going to get to the other 4 functions, but for now just concentrate on these 2, the other 4 trig functions, but just concentrate on these 2. Your derivative with respect to x of sine of x is equal to cosine of x, and your derivative with respect to x of cosine of x is negative sine x. Memorize those. Okay, so for instance, let's say that I want you to find the derivative of y equals 2 sine x. Well, 2 is just a scalar, so when you get the derivative, which is y prime of y, derivative of y is y prime, you can just bring down that scalar of 2 and say, well, the derivative of sine is simply cosine. And you're done. And if you blinked, you missed that. So you might want to pause and rewind. I'm not going to. I'm going to keep moving forward. Let's say that you have it as y equals sine x over 2. You can look at that as 1/2 sine x. And so your derivative would simply be 1/2 cosine x, because you're going to bring down the 1/2 as your scalar, and the derivative of sine is simply cosine. You can rewrite that as cosine x over 2 if you want, but you really don't have to. Alright, sometimes we like to mix some things up. Let's say that your function is going to be 3x squared plus the cosine of x. Okay, that's the sum of 2 functions. This is your quadratic function. This is a cosine function. Just do each one of them separately. Because your quadratic function is a power function, follow your power rule. Your power rule to get the derivative tells you to take your power, multiply it times whatever your coefficient is, bring down x, decrease your power by 1. So this would be to the first power, which is just 6x. And then you would take the derivative of cosine, which is negative sine. So minus sine x, and like that, you are finished with that one. Okay? Alright, let's take a look at number 9. Okay? I think I'll do that in the next video.